All right, so we're moving into taking the derivative of the logarithms, or in this case, natural log. Now, what you need to remember that when you take the derivative of natural log, if you remember last time, we talked a little bit about with that exponential. I said something about copy and paste. Remember that? So, hey, we can copy and paste. Again, kind of the same idea is going to apply here. We can copy and paste this function to the bottom part of that fraction. So whatever is in the inside of this ln, that part immediately gets stuck on the bottom. Okay, so just that's guaranteed right off the jump. That inside piece is going straight to the bottom. Okay? Now, after that, what you have to remember is that the derivative of that inside piece must go on top as part of the product rule. Excuse me, I misspoke. Not the product rule, the chain rule. Right? So whatever the derivative of this inside piece is, that piece has to go on top. Now, that piece may be multiple pieces. Okay? But whatever that derivative of the inside is has to go on top. So as we do this and we look for y prime, what we say here is that this piece has to go on bottom. Like right off the jump, it's got to go to the bottom. Now, what goes on top? 8. It's the derivative of the bottom. Or it's the derivative of the inside. All right? So that one's not too bad. Okay? Venture to guess, this one's probably not too bad. Now, I know what you're thinking. You're like, yeah, But that last one, you sure screwed us over. Yeah, I did. Not even going to lie to you. That goes on bottom, what goes on top? 2x plus 3, do we agree? So 1 over this, and then on top of that is the derivative of the inside piece, so 2x plus 3. All right, that's just using power rule. Okay? Yeah, this one beat your rear end.
Yeah, I think I got it though.
All right, so somebody thinks they got it. What I meant, I'm not going to say your name on video because this will last for an eternity. Do you want to wager?
Yeah.
I got to pause the video to enter into negotiations. Hold on. All right. After intense negotiations, we do got somebody on the hook for about 4 miles of walking lunges. I won't show their answer because it's not fit for broadcast. When you do this one, there's an easy way and a hard way. And you, my friend, did the hard way. I will walk you through the hard way, and the hard way is not good. All right?
Not bad.
Oh, it was bad. Oh, it's worse than you think. You see, if you just straight go with what I told you to do, and you stick this on the bottom, right? So the rule was, whatever's on the inside goes to the bottom, and then the derivative of the inside goes on top, right? That would actually set you up with this kind of complex fraction situation, right? You would have 4 over 2 square root 4x plus 7. That's actually the derivative of the inside. Do we agree? It's 1/2, and then the square root of 4x plus 7 is on the bottom, and the derivative of that piece is on top, right? And now that creates this kind of complex fraction situation. If you can handle that complex fraction, it actually turns out not to be so bad. It's 4 over 2, 4x plus 7. The square root and the square root will combine together to just become 1, right? And then the 2 and the 4 would cancel, and that would give you a final answer of 2 over 4x plus 7. That is definitely the hard way to do it. Like, there is a much easier way. Okay? What's that?
That's pretty much how I did it.
Right, and that's the way most people would do it. If you didn't know the properties, then that's the way you would kind of have to do it. The problem is it creates this kind of complex fraction situation, which is just never a good situation, right? Like, that's just a bad situation in all cases. So don't do it this way. Let's do it a little bit easier. Now, for those of you that are watching, I'm going to delete this little line right here. If you want to leave it up there to look at it longer, press pause right now. If not, I'm deleting it. 3, 2, 1. There you go. Here's the way you could have, if you would have noticed it. Here's the much easier approach. You're given this, right? Let's write it this way. Let's write it as ln of 4x plus 7 raised to the 1/2. Why do I want to do that? What's the properties of logarithms tell me? That I can write that as 1/2 ln 4x plus 7, yes? That the exponent can come out in front of a log, okay? So that's a recall, right? Recall that ln a raised to the b was equal to b ln a. All right. Most people don't remember that. I also will go ahead and throw in, now that we're talking about it, to also recall that ln a times b is equal to the ln of a plus the ln of b. Okay? Why would we want to do that? That would be better than trying to do this problem and doing the product rule. Does that make sense? So if you had something on the inside where you had ln and you saw, oh, it's got to go to the bottom, and then when I take the derivative of the inside, it requires the product rule. Don't do that. Separate the ln's out, and then you can do them as individual pieces, and it's much easier. Does that make sense? Okay. Also recall that the ln of a divided by b is equal to the ln of a minus the ln of b. Okay. Does that make sense? All right. So you having these three properties in hand make a lot of these problems a whole lot easier than what they could be if you try to do them, if you try to brute strength it. All right. By brute strength, I mean you just follow that formula and say derivative of this goes to the bottom, derivative of this piece goes on top, and then you end up with this massive, complex fraction. It's nasty. From here, what do you have? This would be equal to the bottom. You would have 2, 4x plus 7 on the bottom, as this piece would go to the bottom. The 2's already down there, so then this piece goes to the bottom. And then you would have the derivative of the top, which is 4, which would give you a final answer of 2 over 4x plus 7.
So when the 1/2's in front of the ln, it's just acting like it's just there, it's just a different spot.
Mm-hmm. Yeah. Any questions on that? We good? All right, let's try another one. All right, let's try another one. I'll press pause, and you can press pause with me at home, and then you can try it on your own. Let's go ln. Let's go cube root e 4x plus x squared. We'll press pause here. So what would this be? So the first thing to do is recognize that this is the ln of e to the 4x e to the 4x plus x squared raised to the 1/3, right? So that the 1/3 can get moved out to the front. So now we'll move the 1/3 out front, and then we'll deal with derivative of this piece. Yes? So what is that? Well, here we're going to copy and paste this piece to the bottom, because that's what it always goes to the bottom. Right? And then on top, we got to put the derivative of this piece up there. Yes? So the derivative of this piece is what? 4e to the 4x plus 2x. Do we agree? Which would give us 4e to the 4x, 4e to the 4x plus 2x over 3e to the 4x plus 3x squared. Is that fair? We good? All right. So, let me give you one more to try, because we're on a roll now. Let's go y equals ln 5x plus 3 over 3x minus 2. We'll try to find y prime. You know what? Let's call this f of x, and let's find f prime. All right. And again, people want to know, why do you switch? Just to show you that there's no difference between y and f of x and y prime and f prime. All right. There's multiple ways to write derivatives, and this is just one of them. Okay. Let's pause here. All right, so here, this is going to be that recall that we had here, right? So that we recall that if we have ln with a fraction, it's best if we just split them up into subtraction. Okay? So first thing we're going to do here is observe that this is the same thing as 5x plus 3 minus the ln of 3x minus 2. All right. Now, from there, we're going to then proceed to take the derivative of each piece independently. All right. So for the first piece, again, kind of utilizing this copy and paste technique, right? So whatever this piece is, it's got to go to the bottom. And with that, whatever we have here, the derivative of that bottom piece has got to go on top. Minus the derivative of the bottom piece, or the derivative, this piece goes on the bottom. And on that, the derivative of that piece goes on top, yes? Now, you're not done there, although, you probably get partial credit if you get to there. All right, but you do need to finish that. Now, how do you finish that? Well, I do multiply up, multiply up, multiply over. So 3x minus 2 goes up, 5x plus 3 goes up, we multiply over. So it looks, in the final form, it looks like this. 3x minus 2. So that's the first multiply up, minus multiply over, or multiply up here. So 5x plus 3. And then you multiply over, and you get 5x plus 3, 3x minus 2. That's kind of the way I do it. You could also say find a common denominator. I mean, there's any number of ways to skin that cat. Which is equal to 15x minus 10 minus 15x minus 15 over 5x plus 3, 3x minus 2.
I think it's supposed to be a minus 9 on top.
Don't you ever correct me again. Unless I'm wrong, and then feel free to correct me all the time. All right, so 15x minus 10 minus 15x minus 9. You are correct. Gosh. It's Monday. Didn't sleep at a Holiday Inn Express last night. Not feeling all that smart today. Didn't even put a 15x here. You know it's all shaky for me. All right, 15x minus 15x cancel, giving me a final answer of negative 19 over 5x plus 3, and then 3x minus 2. Now observe if you don't split them up, right? Like if you don't split it up and you just take this and copy and paste it to the bottom of a fraction, and then take the derivative of this piece and put it on top, that's going to get so nasty, right? Because this piece, like if you didn't do it, this piece would go to the bottom, and then the derivative of this piece has got to go on top, which would be the quotient rule. Like, oh God, that would be bad. I mean, that would just be all kinds of bad. And at the end of the day, when you simplify, you would get to this. But it would just be really, really nasty to do it, because it'd be 3x minus 2. Like, it just would not be good. Okay? But it would, I mean, you would be able to get to the answer eventually. It just would be a pain in the butt. All right? Does that make sense? So definitely use the rules there that are given to you as those recalls. Okay? All right. I want to show you one more, and that's this problem. Find the equation of the tangent line for y equals ln 3x minus 5 plus 3 at x equals 2. All right. We'll pause here. Damn, responsibility stuff gets in the way. All right. That was on tape. Okay. So in order to do this, we got to find two things. Number one, we need an ordered pair. Well, we know we got 2 comma something. We just don't know what that other thing is, right? So we've got this kind of 2 comma something. Okay? The other thing we need is the slope. Right? Got to know what the slope is. So how do I find the other portion of our ordered pair? Well, the other portion of the ordered pair is found by plugging in x is 2. All right? So we go find the other portion of the ordered pair by so let's go with y equals, let me get rid of that stupid thing. Y equals ln 3 times 2 minus 5, right? Plus 3, which is the ln of 6 minus 5 plus 3, which is the ln of 1 plus 3, right? Now, here's the part that everybody forgets. What's the ln of 1? Ln of 1 is 0. You see, what that's asking us is, when I look at the ln of 1, what I'm really asking is, what this means is e raised to what power is 1. That's what that means. E raised to what power is 1? Well, there's only one way to get 1, and that's to raise it to the 0 power. So, another one of those recall that ln of 1 is equal to 0. In fact, log base anything of 1 is equal to 0. Okay? That's another one of those, probably should have learned this from college algebra, probably knew this at some point in college algebra, and totally forgot it the day after the final exam, and maybe the day before. Okay? But anyway, ln of 1 is 0. 0 plus 3 is 3. So this is ordered pair now becomes not 2 comma blank, but 2 comma 3. Okay? Now, you may ask yourself, if that's x equals 7, so that you get 3 times 7 is 21 minus 5 is 16, what's the ln of 16? Yeah, you're screwed. All right? You need that sucker to either be 1 or e, because those are the two you can do on your own. ln of e is 1, ln of 1 is 0. All right? Anything other than those two, and you got big-time problems. You have to use the calculator, and that would get you a decimal, which wouldn't be the end of the world, but would suck pretty bad.
ln of e is 1.
ln of e is 1, yes. Okay. Now, what's the slope? Well, in order to find the slope, you got to find the derivative, right? Well, the derivative of this piece is simply 3 over 3x plus 5. Or 3x minus 5, excuse me. Okay? What about the plus 3 on the end? Well, the plus 3 goes away, it's a constant.
Oh, that's why I messed up.
All right? The derivative of this piece is just 3 over 3x minus 5. This piece is going to go away, it's a constant. The derivative of a constant has always been 0.
You don't even put it on the bottom.
No, you don't need it. It's just the derivative of this piece. Okay? So at x equals 2, what's the slope? At x equals 2, the slope becomes 3 over 3 times 2 minus 5. So the slope is just 3. Now look how nice that is. You're trying to write the equation through to 3 with slope 3. Hell, it don't get any better than that. Does that make sense? You've lived life right when you get to that point. Oh. Unless you delete it, and then you have not lived life right at all. All right, so we got y minus y1 equals m x minus x1. Yes. Which gives me a final result of y equals, I'm just going to finish this up. This is 3x minus 6. 3x minus 6. We'll add the 3 over. We'll get 3x minus 3. Does that make sense? And that is your final answer. All right, that's your final answer. Okay. We good? You sure? You positive? You know what? Let's just try, just for the heck of it. I mean, just for the heck of it. Just for the heck of it. I mean, just because, you know, we're here, let's have some fun. We're going to go d dx of this. E 5x e 4x plus 2 minus e 6x. We're going to find the derivative of e to the 5x times e to the 4x plus 2 minus e to the 6x. Maybe we'll make a wager on this one too. So when you see a problem like this, you got a couple thoughts. One is the product rule, derivative of the first piece times the second, plus the derivative of the second piece times the first. And that would give you 5 e to the 5x times all this. And then derivative of this piece would be 4 e to the 4x plus 2 minus 6 e to the 6x times that. Combine, bada bing, bada boom. What if you instead made this observation? That this was simply equal to e to the 9x plus 2 minus e to the 11x. Now, you're probably looking at it going like that. No, that's not, I'm not even sure that's even equal to that. If we distribute, it's e times e, right? Base is the same, you add the exponents. 5x plus 4x plus 2 is 9x plus 2. E to the 5x times e to the 6x, bases are the same, you'd add the exponents. 5x and 6x are 11x. Now you may be thinking to yourself, well, why would you want to do that? Well, I don't know. Derivative of the e is this 9 e to the 9x plus 2 minus derivative of this piece is 11 e to the 11x.
That's so much less work.
And you're done.
Well, I'll be gone.
Notice that there's always kind of a couple ways to do these problems. All right. Part of it is, do you recognize things like, not necessarily this, but do you recognize those rules that you can use? And sometimes if you can use a rule, it's much easier than using kind of the standard derivative rules that we have. Product rule, quotient rule, chain rule, those things. All right. Sometimes you can use a rule first with the exponents.
So could we have always done that?
No. So if this is like, let's say, for example, I say we're going to do, d dx, and it's e to the 8x, and then ln, x cubed plus 5. In a case of this, there's nothing you can do but use the product rule. Does that make sense? And it would be the derivative of the first piece, which is 8 e to the 8x. The derivative of the bottom piece, or the second piece, is 3x squared over x cubed plus 5. And then at that point, you would just have to do derivative of the first piece times the second, plus derivative of the second piece times the first. Does that make sense? So you would get as your final result, it would be this times this piece right. Oh, you jackass. It'd be this piece times this thing right, plus derivative of this piece times this. Does that make sense? And then from there, you could find a common denominator if you wanted to. You see what I'm saying?
Oh, it's product rule, yeah.
And that would just be the product rule. So in that case, there is no easy way, right? There is no, the only other thing you could do would be to make this 8x cubed plus 5 e to the 8x plus 3x squared e to the 8x all over, oh, you jerk, all over x cubed plus 5. Right? So, but there's no rule to follow. Okay, there's no rule that makes this any easier to get. And then from there you can factor out e to the 8x if you wanted to, I guess. But, there's no easy rule that allows you to deal with that.
You could just do the other way on the other one because all the bases were E.
Yes, we could do it this way for this one because all the bases are E, and then you can add them together. But when the bases are not all the same, then you have to kind of go back to that product rule, quotient rule deal. Does that make sense? So that's kind of the way that's done. All right, we're going to stop the video there. That's certainly long enough.